A couple of weeks ago, we have published a blog post on local development of Go applications with test containers. In this blog post, we talked about how you can leverage test containers for setting up the local development environment. In our applications, we may use SQL databases, NoSQL databases, or message brokers like RabbitMQ, Kafka, etc. etc. So in order to run our applications locally, we may need to somehow run all those services. But instead of doing all that work manually, we can leverage test containers to automatically spin up all those services as a Docker containers and then start our applications. In this video, I'll show how to create a simple Go application talking to a Postgres database and then demonstrate how we can use test containers for setting up the local development environment, which automatically provision Postgres database. So let's get started. Here we have a simple Go application. Here, if we take a look at Go mod file, we can see we are using Fiber web framework and we are using PGX for interacting with the Postgres database, and then we are using test containers Go Postgres module. And if we take a look at the main.go file, here first we are getting database connection string from the environment variables, and then we are trying to create a connection by calling getDB function. So here we are using PGX library and establishing the database connection over here. And once we got the connection, we are creating an instance of user repository. So we are taking the connection and then instantiating the user repository struct. And on user repo, we have a method called getUsers, which queries users table and fetch all the records from the users table and populate into our users struct, and then returning a slice of users. And here we are creating a new app using Fiber web framework, and then we are creating two API endpoints, one which simply send a hello world plain text response, and another API calling /API/users. We are fetching all the users from the database and then we are returning the JSON response, and we start the application on port 8080. Here, in order to run this application, first we need to have a database, Postgres database installed and up and running, and then we need to configure this DB connection string, and then we should be able to start the application. But here is where test containers helps us. So instead of doing that work manually, we can leverage test containers to automatically spin up the database, and then we can configure the database connection string as an environment variable, so that when we start our application behind the scenes, it will automatically work and take the database connection and starts our application. But we don't want to package any of the local development setup related code into our final application bundle, right? So what we can do is we can leverage Go's build tags feature to isolate all the code that is required for local development setup, so that when you are running the application locally, you can enable that tag so that it will automatically run that code and set up all the required services. But in the production build, you don't enable that tag, so that any of this code that you use for setting up these services won't be packaged in your final application bundle. Okay, so let us take a look at this dev dependencies Go file. So here we have added this Go build tag dev, so that when we run the application locally, we can enable this tag so that all this code will be executed. But during the production build, we don't enable this tag, so that any of this code won't be get packaged into our final application artifact. So here in this file, we have a init function which automatically gets called, and in this init function we are creating a Postgres database container using Postgres 15.4 Alpine image, and we are specifying to automatically invoke this SQL script which will initialize the database. So here if you take a look at this SQL script, we are simply creating a users table and then inserting a couple of records. So while spinning up this database, it will automatically initialize the table and insert a couple of records also. And once the database container is started, we are obtaining the connection string from that database container, and then we are checking whether we are able to connect to it or not, and we are setting that connection string as a environment variable here, okay, which is going to be used by our main function. We are obtaining the db connection as an environment variable, right? So here we are setting it up. So in this application, we are only using one service, which is Postgres database. But even if you are using other services like Kafka, RabbitMQ, or MongoDB, whatever container service you want to use, you can spin up all those containers here and register them here. So here we have successfully started the container and register them using environment variables to be used by our actual application. But we also need to take care of cleaning up those containers once we stop the application also, right? So to do that, we have created a channel and we are listening to sig term and sig interrupt signals here. And in our Go routine, we are listening from the channel, and once we get a input from the channel, we are calling the shutdown dependencies function by passing this container. In our case, we have only one container, but if you have any number of containers, we can pass one or more container references to this function. So in this shutdown dependencies function, we are iterating over all the containers and then terminating them, which essentially stop and remove the containers. So this way, once you start the application, it will automatically start them and then register if required any environment variables required for running your application. And then once you stop the application, it is automatically going to shut down and remove all those containers. Okay, so now let us run this application and see. Now in my terminal, I am at the root of the application, and here I can start the application locally using go run, but here I am specifying the tag dev by specifying like this, and now I start the application like this, and you can see using test containers, it automatically started Postgres Docker container and then starts the application. Now if I go to our application localhost 8080, we can see the root endpoint is giving hello world response, and if I go to /API/users, it is returning all the users that we have in our database. So it is starting the container and our application is configured to use that application, and we are able to see the response. Now if I stop the application using Control-C, you can see our application caught that signal and then terminating this container here. So this is how you can use test containers along with Go's built-in toolchain like build tags and init functions to provision all the required services like databases or message brokers or whatever the services that you are using for your application, and provide a streamlined and simplified developer experience so that you don't have to have a dedicated document that says, okay, first install this, install that, and then configure this, configure that. You don't have to do any of those manual steps. You can provision all the required services using test containers and then make the development much simpler. I will share the link to this blog post in the description of the video, and also if you are completely new to test containers, I would highly recommend you to watch this Getting Started with Test Containers for Go video to understand how you can use test containers for testing, and then you can follow along this guide to experience the same which I demonstrated in this video.